for the most part for this. This is one of the lessons, again, it's basically the first half of this lesson, that if you think that you're not good at math at all, this first couple sections, A and B, are the things you have to knock out of the park. Because there's no math in these first couple sections. There's only, if you have it, it looks like this. You switch the exponent and the index number around, and it looks like this. That's it. You're not multiplying, you're not solving anything, you're not doing things on both sides, you're not factoring. All you're doing is you're following this map with this, I guess if you want to call it a formula, to go from one form to another. So what that looks like, we're going to start by taking things that have exponents, and we're going to focus on the ones that have fraction exponents. We're going to take those exponents, and we're going to turn them into radicals. Now, this kind of makes sense if you think about it, because remember, exponents and radicals are inverses of each other. They're opposites. Since they're opposites, almost everything in math, you can write just as its opposite. So, for instance, adding and subtracting are opposites. So if I had that's the same thing as 5. Instead of minus, I can make plus -4. Any subtraction problem, you can actually make addition. Any multiplying problem, you can actually make division. Same thing with this. Any radical, you can make into an exponent and vice versa. I've seen different formulas where you do a shortcut if there's a 1 in the numerator. I like to do that shortcut because I would much rather give you problems that it's going to work for all of them. Because if I give you a shortcut, there's some students that always do a shortcut, even when I can't. So, the first line, when you have a fraction through your exponent, remember everything, every exponent, every number can be written as a fraction if you put it over 1. If you have a fraction through your exponent, then the index number. The numerator stays as an exponent. It doesn't matter if that exponent is inside your radical or if it's outside your radical. It doesn't make any difference. We're kind of going to do both ways, and we'll talk about both of them later on the back side of this page. So, to the 1/8, same thing as the 8th root, 8 to the first power. Now, obviously, 8 to the first power, you don't have to put the exponent. Technically, everything is to the first power. If you want to put your exponent, you don't have to. If you put it, that's fine. I couldn't care less. For my notes, I'm going to leave it just so you guys know where that exponent went. Now, number 2, same thing with the 5. Just because it's a 5 doesn't make it any different. The 4 is the denominator, so it's the index number, and it's 5 to the first. And again, that one can go inside or it could go outside. It doesn't make any difference. I always write it inside. Sometimes when I do the math, I do it outside, but we'll talk about that later. Number 3, same thing. We have 8, and the 3 is the denominator, so it's the 3rd root of 8 to the first power. Now, if you want to, you can go ahead and simplify that down and say that that's 2. Personally, that's what I would do. I like it better that way. If you don't reduce it down to get 2, if you leave it as the 3rd root of 8, I can live with that because I'm asking you to put it in radical notation, and this is radical notation. Now, later on in the lesson, that is reducing or simplifying. So if I tell you to simplify, then I do need this answer. But if I put it in radical notation, you can leave it in that first one. That's absolutely fine. Either one of those are good. This is also one that not a lot of you guys are going to use this in your calculator, but if you can't find the third in your calculator, a lot of times it's in like a menu somewhere. And so for me personally, I never put a third in my calculator. I always put it raised to the 1/3, just because that's easier to find in your calculator. A lot of those, but that's okay. And the last one, we have 25, and the denominator is 2. The exponent is 1. Now, I've had questions about this one. Do you need to put the 2 and the 1? No. Remember, if it's a square root, you don't need to put anything there. And obviously, same thing we just talked about with the exponent earlier. You don't need an exponent of 1. So technically, the square root of 25 is fine. If you want to go ahead and simplify that down to 5, that's okay too. Both of those answers are acceptable. One is radical form, and one is simplifying going one step. See your work on this. If you just put 5 and that's it, I need to see your work because you can put that in your calculator very easily. This is one of those times a lot of teachers I know will give this section on the test. They'll make a different page of this section, and they won't let you use calculators. I will let you use your calculators. I want you to check your work with your calculators. I don't want you to just do your work. So make sure you're showing your work on this. So go ahead and do number 5, 6, and 7 on your own. So my answers are up there. Sorry, the fourth root of 81, I think is 3. Now's as good a time as any. I'll bring this up a little bit later. Again, if you put the fourth root of 81 like this, that's fine. That's okay for this stuff. But if you ever want to do that, if you ever wonder what the fourth root of 81 is, you can either use your calculator or your exponent sheet. I'm going to try to not give you any numbers that are bigger than your exponent sheet. So the fourth root, you're looking at this column. 81 is right here, so the fourth root of 81 is 3. We'll talk about that more when we get to the back side of this page of simplifying. While I'm thinking about it, it's as good a time as any. Moving on to the next one. Now the only difference, all the ones we've done before have a 1 in the numerator. Again, I've taught this before where there's a separate formula they teach you when there's 1 in the numerator. It's actually the same formula. It's a 1 in the numerator. So I don't like that. I like to teach you the same way every time. So really, you know how to do this one already. This is, the denominator goes in front, and this is squared. Again, that can go inside the radical or outside the radical. Doesn't make any difference. If you put that as your answer, I'll give you credit. However, if I were you, I would simplify it a little bit more. Either one is correct. If I want in radical form, both of those are radical form. I'm not going to be nitpicking on that. I honestly, when I make a multiple choice, I don't know which one I'm going to do. Ten is where we just barely start doing some math. Earlier, I said this stuff, there's really not a lot of math in it. You guys should just memorize it. So we do start some math in number 9 and 10, but I also will tell you, this math is the same thing you guys learned back in like 4th and 5th grade. Some of it. So one of the things you guys did in Algebra 1, you learned the exponent properties. Don't write this down. We had one exponent property that said like x m multiplied by x to the p is equal to x to the m plus p. If you multiply, you add your exponents. Did something like that back in Algebra 1. However, this one, the other one you guys did, is that if you have an exponent raised to another exponent, you multiply those. So if I have an exponent and then raised to another exponent, all we do is multiply those. So if we have x to the third raised to the 1/6 power, we multiply those. So this is the same thing as x raised to the, some room, x raised to the, sorry, decide not to do that, by 1/6. This is elementary school. Now that said, it's been a while since you've done this, so if you don't know how to do this, that's fine. But pay attention because it's not bad. Subtracting, you just multiply straight across. So 3 times 1 is 3. And then remember, if it's not a fraction, you can make it into a fraction. So 1 times 6 is 6. Remember, we want this to be a radical form, and all we did is we put it into an exponent form. The reason I did that is because now you can reduce that fraction, and I do want you to do that. So this one, I will count points off if you don't reduce that fraction. So we should have x raised to the 3/6 is 1/2. Remember, if you don't know how to reduce a fraction in your calculator, if you put 3/6 as a fraction and hit enter, it'll reduce it for you. Last but not least, though, that is the square root of x.
Your denominator is 2, your exponent is 1. That's the answer I'm looking for. I know we had to do a little bit of work in the exponent notation, but still at the very end, that made the radical notation easier. Technically, you could have taken the 6th root of x to the 3rd and then reduced that down. I think that's enough. So I know that one took a little, but again, it's really not a lot because I explained a lot of those steps pretty carefully. This one isn't going to be too bad because 1 6 times 2, again, you multiply those together. 2 times 1 is 2, 6 times 1 is 6. Then you reduce that fraction, that is 1/3. And so now we know that is the 3rd root of n to the 1st. I'm tempted to take this one off or move it to later because we start with a radical. Well, we do start with a radical, but in my opinion, the easiest way to do this one is to make that radical into an exponent so then we can do it like number 9 and 10. The problem is, technically, I haven't taught you how to make a radical into an exponent. That's what we're going to do in a second. But you guys can use your context clues. If it's the square root of 7, it's the same thing as before. Close enough. Where we have the index number is the denominator, the numerator is your exponent, which we don't really have an exponent yet. Again, the 1/4, we're not going to do that yet. That's raised to the 1/4. That's what we're going to deal with. Technically, you could have made it 1/4 over 2, but that's a weird fraction where you have a fraction, but you also have another fraction. So I like to go one step at a time. I make this into 7 to the 1/2. Now I can multiply my exponents just like we did earlier. So 1/2 times 1/4 is 7 to the 1/8. Then once you have that, again, now it's the same thing as before. Your denominator goes as the index number. Your exponent goes as your numerator goes as an exponent. 8th root of 7. That's the last one. Any questions on those before we move on to the you-do section? All right, go ahead and do number 12, 13, 14 on your own. I'll put the answers up here in a second. There, I know you can't see number 12. I kind of scroll past. You can at least see the answer. And again, for number 12, I don't care which one you do it. Again, on the lesson or the end of the lesson, when I'm saying simplify, then I want it to be as simple as possible. But if I just tell you to put the radical form, any one of those will work. Any of those are fine. Absolutely okay. Any questions? Yes. How did I get what? So again, you can leave it this way, that's fine. But I said 2 to the 3rd, 2 to the 3rd is 8. 2 times 2, I think. I should put a disclaimer. All right, now we're going to shift gears. We're going the other way. Now we're going to start with a radical, and we're moving to exponent. But again, it's the same formula. It's the same thing we're doing with these steps. The only difference is we're doing the opposite way. So again, if we have an index number, that's the denominator. If we have an exponent, that's the numerator. Exponential notation, this is m raised to the exponent of 1, because there is no exponent, over 7. Remember, if there ever is not an exponent, you just need a 1 up there. It makes sense because you can't have just the denominator with no numerator. It's got to be 1. Not too bad. Next one, same type of thing. Now we do have an exponent, so that's nice. That's the numerator. The index is the denominator.
Number 11, there's two ways to do this. One way, if you look up at a formula, remember I told you guys earlier that there's two ways to write your radical. You can either have the exponent inside or outside. So if you look at that one, you could just say, okay, so that's my exponent is 3 and my index number is 5, so that's your answer. Obviously, that's the easiest way to do it. But if you do it like we did one of them up here, what was it, number 11, I think? If you do it the same way, if you stick with that theme, this is 7 to the 1/5 power multiplied by 3. And then when you multiply those together, you get 7 to the 3/5. So it doesn't matter which way you do that. You'll still have the end result. Again, just please make sure you're showing work when possible. And number 8, you end up getting 2 raised to the 6/2, which is, we'll reduce that down as 2 to the 3rd. Now, I do need you to reduce your fractions if you have those, or if you can for your exponent. But if you put 2 to the 3rd is your answer, that's fine. Also, if you keep going and say that that's 8. 2 to the 3rd is 8. Doesn't matter which way you want to do it, it's fine. But again, those first 4 are a lot of notation, math in those, knowing how to go from one notation to another. So go ahead and do those next 4. Then we'll start on the simplifying part. All right, I put my answers up here. And there's a couple different ways you can do that one. So I did both ways. I went where you can just go straight to the 2/7, or you can make the 7 through to 4. You can change that to 4 to the 1/7 and multiply by 2. Doesn't make any difference. Get the same answer, all the same. Last one, 5 to the 8/2 is 4, so that's 5 to the 4th. Again, if you leave it like that, that's fine, but you can also keep simplifying down to 6/25. So for this one, if you leave 5 to the 4th, I can live with that because I wanted exponent notation. However, here in a second, the next thing we're going to do is simplifying. If I want you to simplify, then I do want it as simple as possible. 5 to the 4th is not as simple. All right. So part C here, simplify the following. So this is kind of this is where we're actually going to use some of that math. This is where we're going to use some of that notation. And I want to know what is 144 raised to the 3/2. Again, I just want it as simple as I can. Now, again, you need to show your work because I know you can put 144 raised to the 3/2 in your calculator. Your calculator does exponents. Your calculator does fractions. I know you can do that. If you want to do that to check your work, that's fine. But I need to see your work on this. So, a couple of ways you can do this. The first thing I do is I change it to the square root of 144 to the 3rd. You can put the 3rd outside your radical, or you can put the 3rd in the radical. Here's the difference. The first one, you're going to take the square root first, and then you're going to raise it to the 3rd power. The second one, I'm going to take the 3rd power first, then raise it to the 3rd power, and then take the square root of that. Obviously, you don't need the 2's written there either. That's fine. It doesn't matter which way you do, you get the same answer. I personally like to do the one on the left. If you can ever do the radical first, or the square root, or the 3rd root first, it's just going to help because you already have kind of a big number, and it's going to get that smaller before you have to make it a little bit bigger. And one like this, you actually can do it maybe without using the calculator again. The square root of 144 is 12. So then we have 12 to the 3rd. Use your calculator or use your exponent list. 12 to the 3rd is 1728. Interesting. Ends up being 1728. Now, the reason I was saying this is because this actually does get a little overwhelming. The other way to do it is to take 144 to the 3rd power first. Now, that's going to be a pretty big number. Most of the time when you do one like this, I'll have it on our list. This one I don't have on our list, but I guess it's a square root, so you can use your calculator.
So 144 raised to the third power is 85984. The square root of that. So it's on your chart. The good news is on your chart, it's a square root. Calculator. So the square root of that answer, and that's not what I wanted. The exact same thing. Doesn't matter which way you do it.
Now again, I personally think this way is easier. I use a calculator anyway. Most of you guys didn't know 12 to the third. I certainly didn't. So I'm going to use my calculator anyways. So you might as well do this one in your calculator. So it doesn't make any difference which way you do it. You do end up with the same answer.
So number 24, again, same thing. We're going to multiply our exponents. So 3 times 5 is 15, and then we don't have any, it's 3 times 1 in the denominator. Reduce that down. Again, don't put that in your calculator. If you do put that in your calculator, I'm going to count some points off because I need to see 4 to the 5th on your paper. So I want you to reduce that fraction. Now you can do it in your calculator. Use your calculator. You can use your exponent sheet. 4 raised to the 5th is 1024. Earlier, we just didn't simplify. The third root of 9, again, I'm going to change to an exponent. I personally don't like radicals. That raised to the 6th. So when you actually multiply those exponents, we get 9 to the 6 over 3. 6 over 3 is 2, so that's just 9 squared. So you still need to go down and, again, put 81.
So before I told you guys to leave it as 9 squared. Again, that's what I wanted the exponent notation. Now I want you to simplify it. I want it as simple as possible. So 81 is the answer I'm looking for.
For me, it all comes down to using the formula I taught you at the beginning of the class, making sure you know where the index number goes, where the exponent goes, and then using your multiplying, adding or multiplying fractions you guys should know from elementary school, but also can use your calculator. My wife teaches 5th grade, and she talks about how her kids just would love to use a calculator. They want to use a calculator all the time. My wife said, you can't use a calculator on this. They're always so upset because they want to use a calculator. And I tell her, I try to get you guys to use calculators all the time, and some of you guys don't. So this next one, we have 18th raised to the 1/6. Now here's the thing with this one. This is the one this is the hardest one of today, in my opinion. This one is because the same thing we did, and I'm not going to go through the whole thing, but the same concept, the same common mistake on the sum and difference of cubes we did earlier. There was one part of that one where we had, and that one specifically, we had 7x squared. It was not 7x squared, x, the whole thing squared. When we did it, I told you guys, a lot of people did really well with this, and I'm not to toot my own horn, but I feel like you drilled it in your head. If you have 7x squared, that is not 7x squared. It's not that easy. You've got to square both of them, 7 squared and x squared. That's one of your exponent properties. I thought about doing a lesson over exponent properties before we did this, but we only go over a couple of them. I'm hoping they're fairly basic. If you don't remember doing them, I hope you remember what you know now. 6 needs to go to both. 729 to 6. 8 to the 18. 6. That, now we've done this problem before. That's what we just got done doing. The first 3 problems, got 2 of them in one. 6th root of 729. 6th root of 729. Make it into a radical. And then if you don't know how to do this in your calculator, there's 2 ways to do it. Once you've written this down, if you want to use your calculator with the exponent like this, that's fine.
But also, again, we're going to try not to get any of them that are off of your chart when it's like a sixth root like this. So if you use your chart, that's fine. So what I mean by that is use your chart. Sixth root is the exponent of 6. And we have 729. So 729 is right here. So that is the 3 to the 6th. So the third root of 729 is just 3. So at 18 over 6, 18 divided by 6 is 3. Put that back together. That's 3a to the third. In my opinion, the hardest part of that is just remembering that that 1/6 has to go with both of those. If I would have another variable in there, so if it would be like 729, 8 to the 18th, b to the 5th, c to the 6th, that 1/6 goes to every single one of those. Thing that 3 over 2 goes to both, so that's 36 raised to the 3 over 2, and x to the 6th raised to the 3 over 2. So if we're just focusing on, we have the square root of 36 to the third. Now again, this is where if you want to do 36 to the third first, you can. It's just a really big number. I would take the square root first, the square root of 6, and then take that to the third power. It's not that that's easier as much as you're just dealing with smaller numbers. Then the other one, 6 times 3 over 2. And again, you guys also have the added benefit. Again, 6 times 3 over 2, you can do that in your calculator as well. I would like it if I made you show work for that, but I don't even know how to make you show work. So if you put that in your calculator, I can live with that. That's 18 over 2. 18 divided by 2 is 9. So we have 216, x to the 9th. That is your answer. That is as simple as it can get. I will not, 98% sure, give you problems like this, and then at the very end, you still have to reduce your radicals. So that's square root of 36 raised to the third. I'm not going to give you one that's like the square root of 50 raised to the third, where you have to reduce the radical, then take it. I'm not going to do that. I'm going to try not to. If I do, it's definitely an accident. I have a couple you do problems for you guys to do on your own. I would definitely encourage you guys to do these. I know some people skip and start on the worksheet. That's your prerogative. But for some of you guys, again, if you're struggling with this and you want to get as good of a grade as possible, do these problems so you can check your work before you start on the worksheet.
All right, real quick, these are my answers that I got for those. You do problems quick. I know some of you guys maybe didn't get a chance to finish those quite yet, so I'll leave these up. The biggest thing, again, number 28, you can do two different ways. You can either take the fifth root first. You need to take the fifth root first and then square it, or you can square it first and then take the fifth root. It doesn't make any difference. You get 4 for both of those. Again, you need to show your work because I know you could just put 32 raised to the 2/5 in your calculator. It's always a double-edged sword because I feel like there are some students that either do it in their calculator and just put the answer so they miss it, or I have some other students then that they'll find the answer and they'll never check their work with their calculator. So again, you can do it in your calculator to check your work. That's what I highly encourage you to do. The next one, the other thing I want to say with this next one is I did it this way where I took the 2 times the 3/2 first, because that's what we've been doing in class. But some of you guys maybe saw 6 to the second power is 36. So 36 to the 3/2. So that is the square root of 36 to the third. If you did it that way, that's absolutely fine. That ends up being 6 to the third, which is exactly what we had before. So again, there's a bunch of different options for a lot of these. That's kind of nice with math because a lot of times with math, there's only one way to do it. In this one, there's a couple different pathways to go. Again, I'm going to try to make sure the numbers are on your chart. So for instance, the fifth root of 16,807. If you don't know how to do the fifth root in your calculator, that's fine. You can use your chart. That's on there. Same thing with the third root of 1,331. So if you have any questions, let me know. Again, if you want your practice test, I'm hopefully going to have it by the end of the day. If I don't have it by the end of the day, I'll have it tomorrow sometime. I will let you guys know on Google Classroom when I finish that. But definitely, that's an important one.